Covalent and metallic bonds. Module 2, Lesson 7. Covalent bonds. Covalent bonds are a type of intramolecular bond. Recall, tra stands for the bond between the atoms themselves inside the compound. The atoms that make up a covalent bond are nonmetals. Nonmetals can be found on the right-hand side of the periodic table, with the one exception of hydrogen, which is quite often found in column 1. Now I have a question for you guys. Which of the nonmetals would not need to bond to become stable? The answer is the noble gases, because the noble gases already have a stable valence shell, or a full outer electron shell. The noble gases are found over here in column 18. Helium has a full shell with 2 valence electrons, and the rest of the elements in that column have a full valence shell with 8 electrons present. So what are the steps to stability? Well, all elements are trying to become noble. An atom needs stability in that valence shell, which calls for at least 8 valence electrons. Now note, this rule can be broken, but the majority follows this golden rule, and for this course, we'll be looking at filling the valence shell with the magic number 8. So, the covalent bond. The covalent bond operates very differently than the ionic bond that we just looked at. There is absolutely no giving and taking going on. Instead, sharing is used to achieve that stable octet. Now, if we look at the word, the prefix co in the English language means together or something mutually in common. So take an example or two. To cooperate means to work together. Cohabitate, living together. Coenzyme, 2 enzymes working together. Co-hosting, hosting a party together. Now, if we take the word covalent and we put it together, we get this. Co of the word means shared or together. And valence, the valent part of the word, means the outer valence electron shell. So, meaning the electrons are shared between the atoms so as to reach a stable octet. So if we take this example of oxygen and hydrogen, aka water, oxygen brings 6 valence electrons, seen here with the red circles, where hydrogen has 1 valence electron, seen here with the blue X's. When their valence shells overlap, so to speak, they become full. Oxygen now has 8, 2, 4, thanks to sharing 1 here, and the sharing of an electron here. So where were we? 6, 8. Hydrogen needs 2 valence electrons, so by sharing 1 with oxygen, it too achieves a stable valence shell. So here we have a little covalent bonding in action. So note, both of these nonmetals have 7 valence electrons. Both nonmetals need 1 more electron to reach that stable octet. Once the connection is made, where the valence shells come close enough to each other and overlap, a chemical reaction occurs. Now both nonmetals are stable, and we have a compound. A stable new molecule has been created through covalent bonds. Okay, so electron pairs. Electron pairs are formed by sharing electron pairs in the outer electron shell to reach a stable octet. So they can share in 3 ways. You have your single bond here, represented by a single line, and it is a pair of electrons being shared. The double bond, represented by 2 lines, 2 pairs or 4 electrons are being shared. And then you have your triple bond, and it is represented by 3 lines. And here we have 1, 2, 3 pairs of electrons or 6 electrons being shared. There are 2 types of covalent bonds. We have one called a polar covalent bond. This has poles. You can think like a North Pole and a South Pole. And in a polar covalent bond, electrons are not shared equally. So, just like in a tug of war, one side is stronger than the other, and they're able to pull those shared electrons closer to its nucleus. Now, the opposite to this is the nonpolar covalent bond, and you probably guessed it, in a nonpolar, there are no poles. Therefore, electrons are being shared equally. Not one atom is stronger than the other to pull these electrons closer. It's balanced, it's even. So let's take a closer look at the nonpolar covalent bond. So this is where the electrons are shared equally. This is clearly going to happen when you have the same atom sharing electrons, because their nucleus is just as strong. So nobody can pull stronger or closer those electrons to one nucleus versus the other. So chlorine gas is a nonpolar molecule because both atoms have the same pull or strength on the electrons that they're sharing. Doesn't matter how you look at it, they're equal strength. So the strength depends on a couple of things. One, how close the valence shell is to the positive nucleus. The closer they are to the nucleus, the more effect that positive core has. And 2, how many protons are in the nucleus. An element with 2 protons will not be as strong or as positive as, say, something with 7 protons. This is referred to, or it is called, the electronegativity of an element. Polar covalent bonds. So the polar covalent bond, remember, means there's poles. There's a positive and a negative. And this is where electrons are shared unequally. One atom is stronger or more positive and can pull those electrons closer. So water is a wonderful example. And it is this polarity that actually gives water its amazing qualities and lifelike properties for us. So here we have the big atom, here is the oxygen, and the 2 smaller ones are hydrogen. Now, just looking at this, which one do you think would have the stronger or bigger nucleus to be able to pull electrons closer? More than likely, you said oxygen. Oxygen has 6 protons, 8 protons, whereas hydrogen has only 1. So 8 is much stronger than 1. Water is a polar molecule because oxygen is more electronegative than hydrogen, and therefore electrons are pulled closer to oxygen, making the oxygen side slightly negative and the hydrogen side slightly positive. So we will talk more about electronegativity in the next video. There's the negative side because the electrons are closer, leaving the hydrogens more positive. So the last type of intramolecular bond we're going to look at here is the metallic bond. So this type of bond makes what we call a sea of electrons. Formed between metal elements, metallic bonds create a sea of electrons that easily move around the nucleus. Electron clouds form around these atoms. And this explains why metals are such good conductors of heat and electricity. They also are very lustrous and they have very high melting points. Examples of metal, we have sodium, iron, aluminum, gold, and cobalt. Anything kind of in the middle of that periodic table all the way to the left. Now note, metals do not combine with metals to make new compounds. Instead, they make solutions of metals, and these solutions are called alloys. And you've probably heard of some of these alloys: bronze, steel, brass and pewter, for example. Okay, that concludes our video on different types of intramolecular bonds. Thanks for watching. We'll talk to you soon.